Anthropic just dropped Opus 4.7, and they are waving around some impressive numbers. We're talking 87.6% on SWE bench verified, and a massive 1 million token context window, plus 333x higher resolution vision inputs. This isn't just another incremental update. It's a serious statement about the frontier of long context agent work. This matters right now because the race for the biggest, smartest model has been less of a sprint and more of a chaotic marathon. Google's Gemini 3.1 Pro was the talk, but Anthropic just put a credible, measurable benchmark score on the table that puts Opus back in the lead for coding tasks. Adding to the pressure, this release lands the same week Anthropic reported crossing OpenAI in revenue, turning Opus into the default model for enterprise workflows that need to ingest everything from a full codebase to a year's worth of customer service transcripts. For us building software, this shifts the conversation away from who has the prettiest API documentation and back toward raw, demonstrable capability. The 1 million token window means we can finally stop treating context as a precious, finite resource and start thinking about it as a persistent memory layer for our agents. If your application needs to read a 500-page PDF, analyze it against a 10,000-line codebase, and then execute a plan based on that synthesis, Opus gives you the plumbing for that. That 87.6% score isn't just a number for a quarterly report. It means the model has a higher signal-to-noise ratio when it comes to actually generating runnable, correct code snippets. We aren't building prototypes anymore. We are building production systems that need reliable, deep reasoning. And that requires a model that can maintain coherence over immense amounts of data. The market hype loves to focus on the headline number, but the real value here is the reliable capacity for complex, multi-step tasks. The competition isn't just between Anthropic and Google. It's between models that can handle the sheer, messy volume of data that modern enterprise software generates. Keep an eye on how quickly the tooling ecosystem integrates these massive context capabilities, because that's where the real money and the real breakthroughs are going to happen. NVIDIA just launched the Nemotron Coalition, bringing together Mistral, Perplexity, Cursor, and a host of other top-tier model labs, Black Forest Labs, LangChain, and others, under one shared compute umbrella. This isn't just a list of partners. It's a formal, shared data consortium built around pooled training recipes and dedicated hardware access. For the first time, a hardware vendor is actively convening model builders, fundamentally shifting the relationship from simply selling GPUs to controlling the entire development pipeline. This matters because the industry narrative has spent the last year and a half talking about open frontier models, suggesting a democratization of capability. But what we are seeing is the industrialization of openness. By pooling training resources and establishing the Nemotron reference infrastructure, NVIDIA is effectively creating a massive, high-friction barrier to entry. If you want to build a state-of-the-art model, you don't just need the best silicon anymore. You need access to the specific, curated compute stack they are offering. The coalition is designed to solidify NVIDIA's position not just as the chip supplier, but as the mandatory operating system for advanced AI development. The promise of this open front is a shared acceleration, meaning smaller teams can work on models previously requiring billion-dollar compute clusters. But look closer at the mechanics. By standardizing the compute recipes and centralizing the data access points, they gain control over the efficiency benchmarks. The true value proposition here isn't the sheer power of the chips. It's the integration layer, the proprietary software stack, and the guaranteed access path that comes with that hardware. Any startup building a vertical application, a specialized workflow, say for architectural design or supply chain optimization, will now have a direct, optimized path and a single point of dependency through this coalition. This consolidates power, forcing model builders to optimize their architecture for the Nemotron environment rather than optimizing for pure theoretical performance. This move signals a pivot away from pure academic competition and toward corporate infrastructure lock-in. The race isn't just about who builds the biggest model. It's about who can successfully deploy a reliable, cost-effective product on this specific infrastructure. Keep an eye on the terms of access and the pricing models they introduce for the shared compute. That's where the real product implications and the immediate competitive battles will play out. OpenAI just committed to spending over $20 billion over the next 3 years on compute from Cerebras, plus an additional $1 billion for data center build-out, and they're also taking a potential equity stake. This isn't just another vendor contract. It represents a massive, high-stakes pivot away from relying solely on NVIDIA's accelerators for their core training workloads. For OpenAI to commit this kind of capital to Cerebras' wafer-scale engine architecture signals something huge, that the WSE chips have finally cleared the reliability and scale bar needed for hyperscale production. Right now, the entire AI compute landscape looks suspiciously like a single point of failure, built around one company's GPU roadmap. We've all heard the whispers about supply chain constraints and the inevitable, brutal cost curve of training the next generation of models. This announcement is the market finally pricing in the need for true architectural diversification. It's a clear vote of confidence in an alternative compute paradigm, proving that the concept of a single, monolithic silicon solution is negotiable when the sheer scale of the compute demand becomes this enormous. What does this mean for the people actually building and shipping software? It means the compute stack is getting genuinely more complex, and the days of treating hardware as a simple commodity are over. Builders can no longer assume a linear upgrade path simply by buying the newest GPU. You now have to think in terms of architectural fitness. Is your model truly optimized for a wafer scale, specialized memory structure, or are you still writing code assuming a traditional, bus-limited accelerator model? This forces the industry to confront the fundamental difference between brute force speed and true, efficient architectural integration. The cost of compute remains astronomical, and the only way to keep the training curve viable is to optimize the physical silicon itself, not just the software layer on top of it. This is a structural challenge, not a software patch. The competition is now officially on notice. Every major player, Meta, Google, Anthropic, needs to figure out how to build out a multi-vendor, multi-architecture compute strategy, or they risk being stuck paying premium prices for a single type of silicon. The market has just demonstrated that the future of AI compute is not a single GPU, but a sophisticated, expensive, and necessary federation of specialized processors. Anthropic just settled a massive copyright class action with authors, a $1.5 billion payout that makes it the largest copyright settlement in U.S. history. This settlement resolves allegations that the AI company trained its Claude model on millions of pirated copies pulled from shadow libraries, sources like LibGen. The figure alone is a brutal number, setting a clear, high-water mark for the cost of training data cleanup across the entire industry. This isn't just some abstract legal victory for the Authors Guild. It's a concrete, massive financial statement about data provenance. The core issue wasn't whether training the model itself was fair use. Judge William Alsop already ruled that, but where the underlying, dirty data came from. The payout effectively prices the risk of using unvetted, pirated source material, shifting the focus from technological possibility to legal liability. This settlement is the industry's de facto cost estimate for building a defensible data pipeline. For us who are actually building things, this is a cold splash of reality. The era of just scraping the internet and hoping for the best is over. You can no longer treat the open web as a boundless, risk-free data lake. When you're shipping software, your entire stack relies on data, whether it's proprietary inputs, public APIs, or just general training corpora. This settlement forces the conversation to pivot from can we build it to can we afford to build it legally? Developers need to treat data sourcing like it's mission-critical infrastructure, because right now, it is. You have to know the lineage of every single byte you ingest. You need clean, licensed, or demonstrably public domain sources, and you need to document it meticulously. The $1.5 billion is a warning shot, a cautionary tale written in dollars that tells every engineering team to audit their data diet immediately. This isn't a regulatory panic, but a market correction enforced by law. It means that the next wave of large-scale AI models will be built on much more curated, much more expensive data sets. If you're serious about building anything that needs to scale, start treating data acquisition not as an afterthought, but as the single most expensive and complex part of your entire architecture. Microsoft just dropped the April update for Visual Studio 2026, and it's bringing two new agents, a debugger agent that promises to automatically analyze and fix failing unit tests, and a profiler agent meant to sniff out performance bottlenecks. It's a big payload, introducing DevMesh for what they call multi-agent pair programming, and adding those MCP-aware APIs, which let extensions hand tasks off directly to Copilot and the IDE agents. This isn't just a collection of shiny new bits. This update targets the fundamental pain points of modern software development: flaky tests and hidden performance debt. For years, we've been told to write more tests and profile harder, but the sheer scale of microservices and distributed systems means that the manual effort to find the single culprit, the single bottleneck, is brutal. Microsoft is acknowledging that the developer workflow itself is becoming the biggest limiting factor, and they're trying to automate the tedious, iterative loop of diagnose, patch, and retest. But here's the angle we need to look at, beyond the marketing fluff. When you introduce agents that fix things, you are fundamentally changing the nature of ownership. The debugger agent promises to fix tests, but who is responsible when it makes a subtle, incorrect patch? It moves the risk from the developer's finger to the agent's algorithm. Similarly, DevMesh, the multi-agent pairing, sounds like a productivity booster, but it's really a complex orchestration problem. It means the build process is no longer linear. It's a mesh of interacting, autonomous systems. For us shipping code, the immediate takeaway isn't that we have more tools. It's that the abstraction layer is getting significantly thicker. We are moving from writing code that runs on hardware to directing a swarm of digital workers that write code for us. The MCP-aware APIs are the critical piece here, because they finally give the ecosystem a standardized way to pass control between human developer intent and AI execution. This is a massive push toward developer scaffolding. The goal isn't just to write code faster. It's to make the act of writing code feel less like engineering and more like directing a very sophisticated factory floor. If you're building anything complex, anything that involves high-frequency testing or performance-critical paths, you need to start thinking about how your pipeline will interact with these agents. The next phase of tooling isn't about better syntax. It's about managing the trust boundaries between human logic and automated, self-correcting AI logic. Google just dropped Antigravity into public preview, and it's a full agentic development platform that drives a browser, a code editor, and a shell from a single planning loop. They're giving the keys to this thing away for free to individual developers right now. That giveaway pricing isn't accidental. It's a direct, aggressive challenge to every other agentic tool on the market. This isn't just another fancy autocomplete feature. This is a single, integrated environment designed to handle complex, multi-step tasks, the kind of workflow that used to require 3 different specialized tools chained together. The fact that Gemini 3.1 Ultra is the default reasoning model, with pluggable backends for Anthropic or third parties, signals that Google is building a foundational layer, not just a feature. They are building the operating system for the next wave of AI-powered tooling. The move is a calculated attempt to buy mindshare. When you look at the landscape, you have dedicated players like Claude Code and specialized workflows from Cursor, all of them vying for the developer's attention and wallet. Google is positioning Antigravity as the universal default, especially by making the individual tier free. This forces developers to evaluate the whole stack, not just the model output. They aren't just selling a tool, they are selling the entire development experience. For builders, this means the barrier to entry for testing these agentic workflows just dropped to 0. You can prototype complex ideas without worrying about the initial subscription cost, which dramatically speeds up the concept-to-code cycle. The pluggability is key. It means enterprise clients aren't locked into Google's ecosystem if they prefer Anthropic's guardrails, but they are still exposed to the convenience of the unified front end. This isn't about the best model today. It's about controlling the interface where the model meets the code. The winner isn't the company with the biggest model, but the one that controls the most efficient, seamless development surface. Developers need to start treating these platforms not as utilities, but as core infrastructure. We are moving past the era of simple API calls and into the era of orchestrated, self-correcting agents. Get familiar with Antigravity now, because the next generation of product development is going to look nothing like what you're building today. A study out of UCLA just dropped a sobering piece of data. 10 minutes of relying on AI assistance is enough to measurably dull human reasoning and persistence. They tested about 1,220 participants, and the results confirm what some have suspected for years, calling it the boiling frog effect. The kicker is that the users don't feel the decline while they're working, but post-task cognitive tests confirm the performance hit. This isn't some abstract psychology paper. It's a warning shot fired straight at every developer, designer, and technical lead who assumes that just because a tool exists, it's inherently beneficial. We are talking about the subtle, gradual erosion of core cognitive skills, and the metric they used, measurable decline, is exactly what we, the people building the systems, need to pay attention to. It forces a conversation about the true cost of convenience. As builders, we are addicted to acceleration. We chase the instant answer, the perfect prompt, the magic function that solves the entire architecture problem in 3 seconds instead of 3 hours of debugging. We are incentivized by speed, and speed, when decoupled from deep thinking, is a corrosive force. This research isn't a critique of AI. It's a critique of our attention span and our willingness to outsource our mental heavy lifting. We need to stop treating AI assistance as a crutch and start treating it like a co-pilot that requires constant supervision. If we let ourselves get comfortable with the AI suggesting the next line of code, the next paragraph, or the next structural assumption, we risk becoming intellectually soft. The problem isn't the technology, it's the default setting of over-reliance. We have to build friction back into the process, reminding ourselves that the hardest parts, the critical thinking, the lateral leaps, are the parts that actually build the durable, complex systems that matter. The message here isn't to throw away the models, but to re-engineer our workflows. We need to design systems that force human engagement, that make us slow down and justify our assumptions, rather than simply handing us the most statistically probable answer. The future of good engineering isn't about how much AI we can integrate. It's about how well we can maintain our own critical distance from it. Stanford's 2026 AI Index just dropped a 400-page report, and the headline isn't about model size or trillion-dollar valuations. It's about a massive trust gap. The numbers are stark. 56% of AI experts view the technology's societal impact as positive, but less than 1/10 of the American public feels anything but concern. We are now living in a reality where the people building the infrastructure and the people using the resulting software are reading the same technology in two entirely different directions. This isn't a minor cultural shift. It's a fundamental disconnect in perception that impacts everything from adoption rates to regulatory frameworks. The report documents record private investment pouring into agentic capability and sophisticated private deployments, which naturally inflates the confidence levels of the people inside the ecosystem. But while the industry is celebrating acceleration and the next wave of specialized AI agents, the public is grappling with the immediate, visible impacts, the job shifts, the data privacy risks, the sheer opacity of these systems. The industry narrative is one of inevitable progress, while the consumer narrative is one of profound uncertainty. For us builders, this trust divide is the most concrete variable you cannot model, and it's the biggest risk factor on your roadmap. You can build the most technically elegant, state-of-the-art LLM agent, but if the market hasn't internalized why it's safe, how it protects their data, or who is ultimately responsible when it fails, the product remains a conceptual curiosity. Corporate doublespeak loves to talk about responsible deployment and societal alignment. But what that actually means when you're shipping complex, black box systems is that you need to shift your focus from technical capability to demonstrable trust. You have to stop selling intelligence and start selling reliability, and that requires brutal clarity about the failure modes, the guardrails, and the human fallback. Don't assume that impressive benchmark scores translate into market adoption. They translate into a PR headache if the user doesn't understand the risk profile. The gap between the confident insider and the concerned outsider isn't a temporary blip. It defines the next 3 years of product development. If you want to ship something that sticks, you need to build for the skepticism, not the excitement. Your product needs to speak to the anxiety, providing transparency and verifiable control, or you will be building a brilliant piece of tech that nobody trusts enough to pay for. Meta just locked down its AI compute supply for the next 5 years, extending a major deal with Broadcom all the way through 2029. They are doing this specifically to scale up their custom MTIA silicon, the 400, 450, and 500 inference chips, on a 2-nanometer process, targeting a massive 1 gigawatt deployment. This isn't just another supply contract. It is the clearest signal, yet that the hyperscalers are actively building the walls around their own compute stack, refusing to let any single vendor, NVIDIA included, own the entire AI show. This matters because the narrative we've been fed for the last 2 years has been one of inevitable, total vendor lock-in. Everyone thought that because the GPU architecture was so effective, the entire industry was going to become beholden to a handful of high-end accelerators. But look closer. Meta is betting its infrastructure, its multi-billion-dollar data center plan, on building specialized, customized silicon that runs their specific models, their specific workloads. They've cleared testing on the MTI 400, and it's hitting their data centers this quarter. That's tangible progress. For us builders, this means the abstract hype cycle is finally getting grounded in engineering reality. Stop listening to the keynote slides promising revolutionary compute. Pay attention to the supply chain contracts. Meta is signaling that the era of the monolithic, general-purpose compute beast is receding. They want specialization. They want efficiency tailored exactly to running inference at scale. What this tells us is that the future of AI development isn't about having the biggest chip. It's about having the most efficient chip for the job, and those chips are going to be custom designed and vertically integrated. This forces the software layer, the stuff we write, to become far more architecture aware. You can no longer write model code and assume it will run optimally everywhere. You have to optimize for the specific, custom hardware you are deploying on. This is a profound decentralization of the compute mandate. It's not a competition between general purpose and specialized. It's a race to build the most optimized, proprietary stack possible. If you are building software that needs to run at the edge or at the scale of a global social network, you need to start thinking about hardware abstraction layers that account for this rising tide of custom silicon. The playbook has changed. OpenAI just dropped GPT 5.4 Cyber, and the headline isn't about its intelligence, it's about its willingness to break things. Through a new program they are calling Trusted Access for Cyber, they are deliberately lowering refusal boundaries for verified security researchers. This means the model is being trained and released specifically to perform binary reverse engineering, exploit analysis, and red teaming operations. This is a massive shift because it marks the first time a frontier lab is formally tiering safety policy based on customer identity, rather than applying one monolithic global refusal policy. Why does this actually matter to the people of us building software? Because for years, the promise of AI safety has been a single, impenetrable wall. We've been told the model will refuse to assist with anything that crosses a certain line, and that refusal has been the primary feature, not the bug. But by creating a distinct, vetted track for defenders, for the people who actually test the boundaries, they are effectively admitting that the global policy was too blunt, too generalized to handle the nuance of professional vulnerability research. They are admitting that the ethical and functional needs of the attacker and the defender require two completely different rule sets. This is a critical pivot for any company building with large language models. The days of simply implementing a blanket set of guardrails and calling it safe are over. You can no longer rely on a single, universal refusal policy to govern everything from malicious payload generation to legitimate vulnerability disclosure. What they are doing is creating an institutional exception, a high-trust, high-risk environment that treats security researchers as trusted partners, not just as potential rule breakers. For us builders, this means the integration points for defensive AI tools will become far more complex and far more powerful. We are moving towards systems that must dynamically assess not just the intent of the prompt, but the verified credentials and operational context of the user submitting it. This isn't just a feature release. It's a whole new architectural layer of trust and verification that needs to be built into the foundation of any enterprise AI solution. We need to start thinking about identity-gated model capabilities now, because the next wave of powerful AI will be defined by who you are and what you are allowed to do.
The air hits you first. It's heavy, thick with the scent of kelp and burning cedar, a mix that clings to your jacket long after you've left the shore. You're standing at Chesterman, where the roots of old-growth Sitka spruce seem to grip the wet sand like petrified claws, pressing right up to the edge of the Pacific. And out there, the ocean is doing its thing. It's not just waves, it's a detonation. 10-foot swells crashing against the black rocks, sending up plumes of salt spray that taste sharp on your tongue. This is Tofino, perched at the wild, western edge of Vancouver Island. It's a place that feels profoundly elemental. It's where the Pacific Rim National Park Reserve throws its massive, beautiful indifference at you. It's a town built around this incredible confrontation between land and sea. And right now, between March and May, the water is alive. The migration. 20,000 grey whales are passing this coast, slow, deliberate, massive, surfacing just yards from the beach. It's a rhythm you quickly fall into. You might start your day with a sunrise canoe tour with the Tlaokaht Nation, the sound of the paddling and the singers echoing off the massive cedar trees in the inlet. Later, you'll be watching black bears forage across the tidal flats at low tide, unbothered by the humanity. The logistics are part of the story, really. Getting here means a commitment, a seaplane journey, or the BC ferry followed by a 4-hour drive across the island. It's a passage. You settle into a cabin, heated, miraculously dry, against the constant, booming soundtrack of the surf. And when the day's drama has played out, you reward yourself. You find a meal of next-day catch, the kind of salmon or lingcod that was swimming just hours before. It's this juxtaposition, the raw, brutal power of the swells outside, contrasted with the warm, comforting ritual of a good meal and a proper book inside, that defines it. It's not a destination you simply visit, it's one that absorbs you. It demands that you pay attention to the subtle shifts in the tide, the way the light hits the massive canopy of spruce, the quiet reverence of the people who call this coast home. You leave feeling scrubbed clean, not just by the salt spray, but by the sheer scale of the Pacific itself. And you know that feeling, that deep, resonant hum of the ocean, is going to stay with you for a long time.